Hello everyone, and welcome back to my YouTube channel. So in today's video, we'll be looking at the questions that were asked in the recent exam of AHSEC Mathematics held on 9th March 2023. So today I'll be looking at only the questions of question number 1. So the first question, it says that state true or false. On any finite set, capital X, a 1-1 function f from x to x is necessarily onto. So to see whether this is true or false, so let us take a finite set, say 1, 2. Now this set is finite. So let us try to define a 1-1 function from this set to itself. So if I explain it with the help of figure, then it will be more clear to you. So suppose this is the domain. So it contains 1 and 2. According to the question, the codomain and domain are same, so the codomain will also be x. So it will also contain 1 and 2. And this is our function, which is given to be 1, 1. So if this is 1, 1, then what will happen? So either this one will go to 1 or it will go to 2. Suppose 1 is going to 1 and 2 is going to 2. So in particular, I have taken this case. So from this picture, it is very clearly this function x to x is 1, 1. Now let us see whether this function is onto or not. So what is asked? If it is given to be 1, 1, then it is necessarily onto. Now if you remember the definition of an onto function, what it says that the range of this function must be exactly equal to the codomain. Now if you look at my example, here the range is this 1 and 2. So range is 1 and 2, and which is exactly same as my codomain, and my codomain is just my x. So from this particular example, you can clearly get an idea that if you have a 1, 1 function, then, and moreover, this function domain and codomain must be same. So if you have a function with same domain and codomain, and if it is 1, 1, then it has to be onto. So this answer is true. Now let us look at question number 2. It says that if cos inverse of x is equal to y, then the value of y is, so here 4 options are given. So we have to select the correct option. Let me tell you the answer first. This is the correct answer. Why? Because we know that the cos inverse of x, okay, is defined only if your cos of x is a bijection, that is both 1, 1 and onto. It's a bijection. Bijection, that means it is both 1, 1 and onto. 1, 1 and onto. Because we know that the inverse of a function is defined only if the function is a bijection, that is 1 1 and 1 2. And if you look at the figure for cos of x, the trigonometric function, cos of x graph, if I want to draw it, how will it look like? So at cos of 0, it will attain the value 1. And we know this trigonometric function, cos function, is periodic, so it will go on like this. So in the next, this is 3 pi by 2, and this 3 pi by 2, it will go up again. And cos 2 pi, it will go to 1. Similarly, minus pi will come down here. It will go like this, and so on. We know that cos function, this is not bijection if I take the whole real line. So this is not a bijection on R. So in order to define the cos inverse, we have to make it a bijection. We have to make it 1 1 and 1 2. So what we do, we restrict the domain of cos of x. We restrict the domain of cos of x such that it becomes a bijection. So how we restrict? We restrict in such a way. So we can restrict in so many ways. So let me restrict from 0 to pi. If I restrict it from, and within this, your cos function will be something like this blue line. So if I take this domain, then if I take this domain, then your cos inverse will be bijective. So definitely, if I consider this as your y, so your cos inverse of x will always lie in 0 to 1. And this is not true. Second option is wrong because 0 can be included here. This is also called your principal branch or principal branch value. And this option number C is wrong. Why? Because in this particular region, your cos x is not a bijection. If you take minus pi to pi by 2, if you take this region, you take this minus pi to pi by 2, cos x will not be a 1 1. In fact, it will not be 1 1. That means it will not be a bijection. So the inverse will not be defined. Similarly, option D is also wrong. So the correct option must be option A. So this question says that the number of possible matrices of order 2 with each with entry 0 or 1. Okay, so that means we have a matrix, say A, B, C, D. And what is the condition? The condition is that your A, B, C, D can take only value 0 and 1. Okay, so it's obvious. So here you can do it manually also, or just we can think of, you see here, this A, from here you can see that A can take how many values? A can take 2 values, either 0 or 1. Similarly, B also can take 2 values, either 0 or 1. C can take 2 values 0, 1, and D also can take 2 values 0 and 1. Okay, that means what? Here each entry A, B, C, and D, they can be written in 2 ways. They can be written in 2 ways. Okay, and in together, how many entries are there in this matrix? I have 4 entries, and there are 4 entries in together. So in total, number of possible matrices which I will get will be nothing but 2 raised to the power 4, which is 16. Next, what do you mean by critical point? It's very simple. Critical point means, what is critical point? Critical point, this is a point. Suppose you have a function f. You have a function f. So critical point is a point in the domain of the function f. Okay, so let us say critical point, say C is a point in the domain of f such that if you take the derivative at this point, it gives you 0. So this C which satisfies this equation is called your critical point. Very simple. Next, give an example of a function which is continuous on R but not differentiable therein. So the very easiest example is, just take f of x is equal to mod of x. Okay, this x is real number. So how this the function looks like, you know, mod of x is a function. It looks something like this. Is the origin. At this point 0, your curve is having a sharp edge. So if you have a curve with sharp edge, then at this point you will be able to draw more than one tangent. That means, in fact, so many tangents you can draw. So as soon as you can draw so many tangents at some particular point of a curve, that curve can never be differentiable at that point. Okay, so I can say that this function is continuous everywhere on R, but not differentiable at x is equal to 0. Okay, similarly, if you think that this function is too common, just take f of x is equal to mod of x minus 1. So similarly, this function is continuous everywhere on R, but this is not differentiable at x is equal to 1. Same. Okay, so the previous one is good enough. So how to solve this? So what you do, you just integrate both sides. If you integrate both sides, what you will get? You will get f of x is equal to this one. If you integrate, this will be x to the power, right here, x to the power 4 by 4 into 4. And this will be 3 times x to the power minus 4 plus 1 by minus 4 plus 1 plus integral constant. Okay, so how much we are getting this? So here 4 gets cancelled. So here 1 3 will come minus. So this will be x to the power 4 plus 1 by x cube plus c. This is my f of x. So here one condition is given. F of 1 is equal to 0. From there we can find the value of c. Now if I put f of 1 is equal to 0, so f of 1 will be what? It is 1 plus 1 by 1, that is 1 plus c is equal to 0. From here I get c is equal to minus 2. So if you put it here, the value of minus 2, your f of x becomes x to the power 4 plus 1 by x cube minus 2. Yeah, this is the answer. That's an easy question. So what is this? If you look at this question, you don't have to do anything. So here, either if you want to write one more line, you can write like this. And this is, if you square it both sides, you get something like this. Even it is not required to do. So from here, you can see that the order, okay, highest order is 2. But since this equation is not a polynomial in terms of your dy dx for y, because due to this trigonometric term, so your degree is not defined here. So the answer is order is 2, the degree is not defined. In this question, it is given that 2 lambda a vector is a unit vector. So if this unit vector, then we know its magnitude, if you take it, this will be 1. So if I separate this will be, say, 2 lambda, and this is like this, which is equal to 1. It is given in the question that this lambda is also non-zero, so I can shift this in the denominator this side, cross multiplication. So this will be 1 by 2 lambda. And it is given that small a is the magnitude of your a vector. So this a vector magnitude can be replaced by small a. So this is 2 by this. So your option number 4 is the correct option. So we want to find the Cartesian equation of this given vector. So we know r vector, position vector, I can write it as xi cap plus y j, sorry, this is y j cap plus z k cap. Therefore, what will happen to dot product of this? So if you take the dot product of these two, so this will be x plus y minus z is equal to 2, which is the Cartesian equation of your plane. What is Bernoulli trial? So this is a definition from your probability chapter. So what is Bernoulli trial? So in Bernoulli trial, let me just write the definition. You can get it from your book also. It's very simple. It is an independent trial which have only 2 outcomes. Now say we, namely, one we call it success, or another one we call it failure. So this is our Bernoulli trial. Thank you so much for watching.